Hey, what's up, everybody? Hey, MP here. Today, let's talk about microservices. So, there's this really cool website called DataCamp, and it allows you to do really interactive data science related projects. And the content is very well done. And the way that they have accomplished this is through this sort of microservice architecture. So whenever I'm on a project at DataCamp, if I load the page, it's going to have two things. It's going to have the instruction set on the left-hand side, and then I see this Jupyter Notebook loading indicator. So what that is doing, most likely, is it's spinning up some sort of containerized or virtual service that is an instance of Jupyter Notebooks. And it's loading in the assignment into that notebook. And as you can see, it's doing this on every page load. Now, by doing this, it allows you to give a really interactive experience to each student that is taking your course. And it can do that safely, and it can do that in a scalable way through what I believe to be some sort of containerized architecture. So how might we be able to accomplish this using, so that we can put this into our new Hack CMS sites, or really any sites? I put together a little Node.js application that attempts to do that. So what this application does is it's a very simple web server. And what it does is whenever you visit an endpoint at this web server, it uses a series of Docker commands to spin up a container that is, in this case, a Jupyter Notebook. For you, on your behalf, it's yours. It's specific to you. You have this container. You can do whatever you want with it. So what does that look like? If we start the server, we can go to localhost. What does it say? 3000. And at first it's not going to work because I need to first log out from my old session and then return here. So there we go. So what that did was the web server recognized that I don't have a container started yet, and it started a Jupyter container on my behalf and forwarded me to that URL. So to illustrate this, let's start a new notebook page, and we'll save it, and we'll go back, and you can see that that's my newly created notebook. Okay. So what would happen if another user went to that same site? What would they get? Let's try it out. So it's going to pause a second, and then, like magic, they are going to be brought into this new Jupyter server. And as you can see, they don't see my work. So this person would start a new assignment. Hit save. Just like that, we have a container. We have two different containers that were spun up on demand. And you can do this pretty much until your resources just fall over, which takes quite a lot, actually. So if I can trigger a new one and just say new. And what new will do is it will force me into a new notebook each time. so it won't reuse the same notebook. So here I am spinning up new containers on demand. Each are totally segmented by themselves so that the students can work on their assignments without seeing each other's. So that's a lot of containers. We can look and see, here's a little application that's monitoring all the containers that are going on. So you can see, so I can see all the containers that were just created by me opening up all those web browsers. Pretty cool. Now, what if we took that one step further? So we know that we can have on-demand containers. And by the way, this isn't just Jupyter. This is also, it can be any application that you put in a container. So for instance, there's RStudio. RStudio is in a container. So if we wanted to, we could just spin up an instance of RStudio and we would just have it available to us. Okay, now I don't have this in the application yet. Why is that not working? Oh, I'm sorry, wrong port. Okay, so just like that, we can spin up an instance of RStudio. So imagine the same idea of containers on demand. We could do it with Jupyter Notebooks. We can do it with RStudio. We can do it with any application. So just keep that in mind. Okay, so now we've proven that we can start containers on demand, right? How would we preload assignments into these containers? So picture this. You have your assignments, and the assignments require some pretty sophisticated technology for them to operate in. So if we take a look at a GitHub repo from our PSU Astro 528 course, these labs are done using Julia notebooks. So these are notebooks that reside inside of Jupyter Notebooks application that are configured specifically for Julia. What we could do is the assignments in here can describe exactly what architecture it requires for it to operate. So if we look at Docker Compose, we see that this requires a very specific Jupyter notebook, one that was set up specifically for Astro 528. Okay. Now that your assignment knows exactly what Docker image it needs to operate on, how might we preload this assignment into a Jupyter Notebook on demand? Let's see if we can do that. So let's go back to localhost 3000. And let's add some new query parameters. This little web server also gives you the ability to define a public GitHub URL to pull down. Or I'm sorry, just a Git URL. So if you put a query parameter of repo, it will go out and clone that repository and place that inside of your Jupyter notebook for you, or inside of your Docker container for you. Let's also specify which assignment we want to render immediately. So let's say this exercise 1. We're going to put path should head into notebooks and exercise 1. Let's see if that works. And I need to first log out, of course, because I made some changes to the Docker containers without this application knowing. path was notebooks slash lab 1 start slash exercise 1. And just like that, we've preloaded this assignment in a Docker container on demand. So now I can do my assignment here. I can then run the tests. So we can see it failed. And then the explanation, it says that we should find this error and fix it. Yay, we found the error, we passed the test. And we're gonna click save. I'm gonna go back to my container. Look at that. We have our completed assignment. So that is containers on demand.